don't know if that would be a good idea to combine with a database program like MySQL or something like this, like sending some queries. If that would be.
I mean, I never tried. I experimented a little bit with H5, logging to H5, and that worked unbelievably fast in just doing result evaluation, because it's just designed to filter through some terabytes of log data. But I could never come up with a small structure, and so it was just hackish and ad hoc for exactly the simulation I was building. So that was scrapped. And now I'm back to writing text files again.
Basically doing the same writing text files. So actually we started to write a couple of Python, but it's a bit more like Python scripts, but Python scripts to control simulation and stuff. So we do some kind of performance parameterization. So we just run starting simulation runs in different cores. So that's what the initial idea to write some Python scripts, and then we came up with when we could do some kind of evaluation step and visualization step with Python. And what we basically do is that we lock the stuff in Scala files and vector files, and grab out the interesting things at the end of Python, and write them CSV files, and then do some aggregation stuff in the end, and then at a later point we can also do visualization with Python. That's basically. That was sometimes, but I found it very slow, so I was not really happy with that. So, but I made it was really and I was thinking about like using some kind of a database, so I can archive stuff and know where it is. But nowadays it's just file-based, folder-based. Yeah, and that could with Python is also like, well, it takes a shitload of time to parse text files. But we do it in a really stupid way, but it's noticeable, and I definitely use some machines with multiple cores, so you can.
I think the solution would be to make it basic so that you can pay the price unless you really access the data. Just I'm not sure if it can be done in R.
Yeah, it can be done. There's some smart caching libraries that can link evaluation or
I think it's the solution so that you could just load all the vector files or the single vector file you have, and unless you access the data, it's going to be fast.
Yeah, it was just that while building all of that crap, I think it's now a mixture of some kernel pre-processing, because Python doing a little bit of mid-processing, and then R doing lots of post-processing, caching, and whatever. Yeah, and while writing that, it occurred to me, well, I can't be the first one or only one in this world who is doing that. I might be just doing it
maybe all the others are not doing the analyzation, just model.
We have this R plugin for which can load on that vector file and scale it. Have you used that?
Yes, absolutely.
Then you could, in theory, you could do everything in R. No?
It's too slow.
Too slow?
Yeah. If you have, I don't know, gigabytes of vector files, this is horrible stuff. So all I'm doing is just the same. I use Perl or Python and just pre-process it.
Yeah, but it's possible to disable vectors selectively based on name, and you can also limit the recording to time intervals. So is it not possible to disable the vectors that you don't need momentarily for the simulation?
It actually runs, I think it runs 1,000 times faster if I disable certain vectors, but that's still too slow to kind of chew through 500 gigabytes of log data. So it's interesting.
Another solution would be to create some kind of to put something like a filter between the signal and the recording. So we have these recorders using this property-based statistic declaration. You can write new data recorders, and then you can, for example, replace a batch of 100 numbers by their average or something like that. If that's suitable, and that would.
Well, at the moment I'm always logging both, because this gives me the opportunity to kind of post-process the vector file and just read it part of it. Because if something fails, I don't want to do the simulations again. They run for a few months.
The filtering is bad because it prevents you doing nothing.
So the filtering is, do you have several gigabytes data structures?
I think we need to look at that problem.
Okay.
migrate series from?
If you're using a text-based format for vector files, and if you use binary format, it could be faster.
You have these smart indexes into the
Yeah, we do,
files,
yes.
right? And that should speed it up much more than it feels it does. So, right.
Yeah, with the index, you only read you can read specific vectors out of the file without reading the whole file, but reading all disk blocks.
And that is being used by the R package,
Yes.
right? And maybe just the
I'm not
think-
sure,
I
I'm not
think
sure
it
why
is.
the data is loaded at all unless you really access the data in the vector from R.
Yeah.
So if you're just messing with, I don't know, 1% of the vectors, why are all the others are loaded? I mean, it's just in the file, who cares? You didn't access those data. So we could just ignore them unless you really evaluate something that needs it.
And then maybe it's just R, which is very slow.
Yeah, I was just saying that I don't think the problem is the vector format. I think it's fine. I mean, the indices they work, but I think it's R that is just ridiculously slow.
It is.
It
It's
is.
a poorly designed language as
Yeah.
well.
I heard there's a version of R that is slow.
Yeah, the language is fine. I think
No.
Revolution R is some manages faster than the default R or open source, whatever.
Is MATLAB faster?
Can't be slower.
Copy
data and so it's faster. I mean, I can read the vectors just fine in Perl, and it's super fast. I mean, it works perfectly, and I just output some coordinates to draw an arc. That works fine, but I don't have the statistics tools that I need. So I don't know. Maybe I should just migrate to another statistic tool because this is so horrible to use now, and I don't think it's on this for at all.
Interesting, because I think in Perl you probably don't use the index, so you read all the all blocks in the
Yeah,
file.
still faster.
Still faster, yes.
No problem.
Yeah, I think R is doing just crappy stuff when you read the data frames.
Yeah.
If you use data tables, that's so much faster. And you can just use it like a data frame. But what comes out of OMNeT is a data frame. So
With R there is some kind of R package which lets you use SQLite
it's
database.
yeah.
Yes, and you can issue SQL tables as well. So do SQL queries.
Oh,
That-
on a data frame or on a file?
No, on a SQLite file.
Oh yeah, I tried that also. I wrote a small SQLite result recorder that just records vector files to .SQL files, and that was fun. But the SQL statements were just selecting a few hosts and selecting a few submodules and then aggregating stuff. That's not really much fun in SQL.
When we implement the R package, we were like hesitating between R and the Python way of doing it. Like Python has mathematical visualization package you use for Python. Matplotlib, yes.
Yeah, the SciPy, which is quite amazing on
Yes.
some time. So there are really quick packages. So I'm not really huge fan of Python either right now at some point.
But then I had a look at the statistical functions available in the Python library, and it wasn't that much. And I thought, okay, we'd better go for R because the whole thing is about statistics.
Well, I think you should definitely look in the SciPy package, and also there's some amazing packages for impression stuff. If you look in, I think it's Panda, so that's a really nice packages.
Yeah, Pandas is fun to use, and it's so much faster than.
Well,
But to be honest, they have been growing very fast. 3 years back, that just wasn't available.
yeah, absolutely. Yeah. But I've got also the impression that everybody's hacking his own script.
So actually, we do almost the same that you do. We have log files, particularly when we want to debug something. We filter them before loading into R, because the reading of the file in R is quite slow. It can take from half an hour to an hour, and then it actually takes a lot of memory to produce all the data. Maybe filtering the data while it is being loaded would help, but we do it offline. We say we want to select these models and we do the same thing and then we need to R. So you're not alone.
Thank you.
And I wanted to add that I liked very much the way the parallel simulation that Mirko Stoffer presented deals with the initialization in a very reproducible manner by chaining the state, the global state as a parameter while the initialization is going on, because then it's possible to initialize things in parallel quite easily, using global variables without actually using global variables. It was a very nice idea.
Yeah, so it's also on the web page where the code is, so you can visit if you want.
So any other more general topics? I mean, there was one topic regarding this maintaining of software modules that Michael was raising. Yes. So it's yeah, it's about the OMNeT framework. That basically we are already maintaining the OMNeT framework currently. So 11 and one Zoltan and one colleague is not here at the moment, and Rudolf. Actually, I don't do that much work on the OMNeT framework anymore. And the thing is, what we have time for is basically maintaining the code base and do like restructuring, refactoring to keep the architecture, the framework the same. What we don't really have time for is develop a lot of new models. Sometimes we develop some protocols from scratch, but really we don't have that much time for that. And what we don't have is we don't have enough expertise for every single protocol that's in the OMNeT framework. So it very often it occurs that sometimes we get patches for this protocol or that protocol, and then we have to read the specification and understand what the protocol exactly does, better to be able to assess whether the patches is correct actually. So since almost everybody uses the OMNeT framework nowadays, I think it would probably make sense to get the community involved a little bit more into the development of OMNeT frameworks and discussions, and especially like code reviews and maybe maintenance of some modules. Yeah, the question is a little bit how to implement this then in detail. I mean, yes. I think in general, I mean, most of the people here would agree on this, to have a more community-driven maintenance concept actually. Does anyone see reasons against such an approach? As far as from my experience in the open software source community is, some people start with the maintenance and then declare other people where they know they have decent knowledge as a maintainer. Mm-hmm. And you have a code review policy that says, you reply in this amount of time, for example, and so on. And then, if you have people who are involved and want to contribute, that actually works. But I think this is one important thing, that you need a code review policy. Mm-hmm. That is transparent to the outside people. Yeah. I think Well, in the first place is experts to different protocols. So if we could have a list of some people who are expert in 802.11 different versions, tons of variations. And then when we receive a patch for 802.11, then we could ask these people to review the patch and assess whether it was good or not.
Yeah, I mean, from the tooling side, I don't know. I mean, but you have in mind some code review pool of people. You know, okay, this guy is knowledgeable in this topic. I don't know if GitHub provides interfaces for this stuff.
I think the user control is not as much fine-grained as you would like to have. It's more like you own the repository or not, and you can contribute or not. You would like have something like you have a folder, for example, you can manage the pull requests, for example.
Yeah, you can declare groups in advance, but you cannot allow people to assign to specific groups. They don't have specific maintenance.
But it is possible for anyone to open a pull request, and it's possible for anyone to comment on the pull request or to comment on the
Yeah, but as far as I understand, Anash, he wants to assign them this pull request to a specific person who is knowledgeable in this field.
I think there's a trade-off to be made between how knowledgeable the person is and how much time the person has.
I mean, and really to connect them.
Well, and also between how much knowledge the person has about the protocol and how much they necessarily know about the current state of the
framework
itself. So it might be sufficient for the expert simply to comment yes or no, you know, yes, no, needs some work, and then because there really need to be two decisions. Is the bug fix correct relative to the protocol, and then, oh no, does it break horribly if we put it into the current version of the code? But maybe those can be two separate decisions, and one of them could just be an informal comment on the pull request, and if it comes from one of the right people, then somebody on the OMNeT side, which might or might not be the same person, could say, yeah, it looks fine, you just pull it in, or no, it's going to break other things. So in a little bit, there's two different pieces of expertise.
The thing is, this would probably mean a departure from the way it's currently managed in the right? Right now you try to enforce this linear path of commits, and everything's being squashed in linear history, and that would just be overlooked, because then you would have forks and pulls in history.
Well, not necessarily. I mean, if there's a topic branch, we could still, and if the topic branch gets into a good state after a series of reviews, we could still rebase it to the top of the master branch, and then.
The thing is, how do other big projects do it? I mean, I know from Tiki, for example, they also migrated to GitHub. When outsiders code contributions, and usually people on the Contiki main core team, they check them and they say, okay, that's good, that's not good. They have their Travis integration to do automatic build up and see if things still work afterwards. And at the end, there's a small group of people who decide, okay, do we accept this request or not? And the question would be, who would be on this?
That would be Rudolf.
I mean, we have the same strategy with YOS operating system, and usually this group, these core maintainers, should also be not super small, because the people are not working full time on this. And I mean, what we do in this open source project is, you are aware of people who spend a lot of energy to the open source project, and if you see they're doing good work, then you ask them after a certain amount of time if they are willing to be a maintainer, and then they're included in this maintainer group. And needs to follow the corresponding policy. But I mean, I would not limit this core maintainer group to, for example, 3 or 4 people from the already existing OMNeT core team.
I mean, there are like, take a look at the OMNeT, for example. OMNeT framework is, there's just one maintainer, but he's very active, and usually it's no problem actually to contribute to OMNeT.
Yeah? I don't think so.
Yeah.
So I think I have still an open pull request, and actually the code quality of the OMNeT framework is really poor. So I was starting using Coverity because I was looking for bugs. And the thing is with Coverity is you compile your code and with some special command with Coverity tool, and then you upload the tab or some kind of database. You don't really know what it's collecting. But you upload it on the website, and then they start some kind of scan. And if you don't define components in your project settings, it scans everything, and started to scan the OMNeT package for me. And this was resulting in, I don't know, hundreds of errors, which were like, and some are really critical, like, so. And apparently somebody hasn't really looked into that.
Also,
and so
that's the thing. I mean, there's just one maintainer, so there's just one person trying to maintain everything. It's just Rudolph. It's bound to fail. And OMNeT is not good in terms of code, in terms of code quality. It's very dynamic. Alfonso, he just adds feature, and he's very active in participating in discussions and everything. But there's just one person spending a lot of time, and I think OMNeT is even bigger and more people, many more people using OMNeT framework. So this distributed group, and with probably people that come and go, maybe, I don't know, not a small time base. That's the only way of doing it. Just with 3 people on the core team or 2 people, even though you do it full time, but not the full time. You have other things to do too. So that's the only way to distribute it in a bit.
Yeah, but I think I don't really want to bash him, the maintainer of OMNeT, so and he can't really defend himself here. So, but if you submit a pull request, and it's a really tiny thing, and it's obvious and really an error, so it doesn't really take that much time to review it. You should just accept it. But I think it's open for 1 year or 2 years now. So, and if you watch the mailing list discussions, it's really like he always tries to answer the mails, but it's more like, well, read the fine code and you probably will understand it. And the result of that is that so there's no documentation at all. Yeah, so you directly if you click the link on the OMNeT PT website, you directly land in the GitHub repository. And as a result, what happens is on the mailing list that if you ask a question, like I did with the energy model to understand how the battery works and that stuff, so that was really, the answers were really helpful. And at some point I figured it out by myself reviewing code. But I'm still getting mails from people which were searching the net for questions like how the battery model works and asking me, well, apparently you figured it out probably, how did you do it? So there's apparently something wrong with that.
There are a lot of problems in the OMNeT battery model. As far as I can tell, the maintainer took the mixing code, but none of the tests and none of the documentation, and kind of put it in. Because my name or my email is in there a couple of places, and every so often I get mails from people who just can't get it to work. And I go, but before I realized that this is what had happened, I would chase down for hours trying to figure out what was. I'm like, wait a minute, that test case, this test case, and it wasn't until I realized that actually pieces of that had migrated into OMNeT, but without the tests and without the documentation, that made it kind of hard. I mean, that's one of those risks of releasing something open source and saying, here's some code, go do whatever you guys want with it. It can sometimes end up places that
take it or leave it.
Yeah, the problem is though that I wanted to maintain the version that I did with Maxime that I actually felt responsible for. I wanted to fix bugs in, but then there are all this other version out there, and I get questions like, oh, I don't know, and that can be.
But I think it's a good point with OMNeT, and I think it's a general problem for the many community programs or projects that we have in the OMNeT community. On the mailing list, there are usually 2 or 3 types of questions. Either I can start OMNeT, or I can use Windows version, or I want to use this or that framework, and there is no manual, there is no instructions, there is no how to something. So how does this work? or it's something specific went wrong, some segmentation fault or something else. So those usually the three types of questions that come up. And there are so many modules that are not used anymore, not maintained, and well, it's always hard, yeah. And I think with OMNeT we have still the ability to build a big catalog of frameworks or models come together that have been maintained and still will be maintained in quite some time.
But are you actually flooded with pull requests, or people are more like submitting patches down over the mailing list? Because I don't really follow the mailing list of OMNeT. Because I just was briefly checking, but there are just 4 pull requests. Well, some are quite old, but...
No, we are getting pull requests basically regularly from 2 people or groups.
Okay.
One is Alphonse Loriza, of course.
Yeah, I thought that.
And Beatrix, and it is about SCTP.
Mm.
And do we have any other maintainers, any other protocols? I don't remember now. No. And then occasional bug fixes, but very, very rarely.
But I mean, those 2 are like the current maintainers of still active development or protocols under active development, right? The CTP, I think there's still some work going on there.
Yeah, but we're also fixing bugs and doing things. So if people are using it and report a bug, and we know about it, we try to fix it and submit a patch.
So yeah, you have a separate bug tracking system, or people just write you mail?
Yes. Or scanning the mailing list, and if someone asks about SCTP, we try to answer. However, what makes our life hard is that at some point of time we don't know which branch we should patch against or work with. So we have also an internal version which we use when we develop the features, and at one point of time we try to pass it over, make it publicly available. So that's one thing, and the other thing is that changing the code base for white space changes, renaming, restructuring, whatever. This makes it hard for us to maintain our stuff. So I mean, give out clear rules what you do, follow that, and don't change that. So don't figure out now we use different naming scheme in OMNeT. This is easy to do for your stuff, but it's hard to backport into other things because we need to manually go to the diffs and see, oh, this is just renaming, this is the feature we have provided, this is something else.
Okay, for these 2 specific issues, so there are two main branches actually. There's a master branch, which is always contains the last stable one, so it's now the 2.x version. And there's another branch which is called integration, and this will lead to the 3.0 version. And in that branch, we changed a lot of things, so there's a huge diff against the stable one. And everything else is basically a short-lived topic branch. Everything is short-lived topic branch, and they can be rebased or deleted or whatever.
I mean, just document where people should work against it, and what kind of coding tool, I mean, how you want white spaces, or what kind of tool you run to normalize your code. Just make it available so people can say, okay, finally I want to submit this code, so I just use your tools, I follow your rules, and then the patch is easy.
I remember that there are some coding guidelines, but they are very old and very inconsistent. I mean, inside OMNeT they say something else, and on the web page and the sandbox wiki area, there's like 3 or 4 years old documentation that says something totally different. And then there's the code formatter options in Eclipse that make some different things too. And that changed from time to time.
Okay, it's got to be for this formatting thing. We finally found a good tool to format the source code, which actually can handle all the corner cases, has decent amount of options to make the source look like we want it. And we have this the tool and the scripts checked into the OMNeT. I think the scripts directory. So we're going to format all source code with that. So if somebody maintains a fork of OMNeT, for example, and they run the same code formatting tool, then there won't be so many differences. it will be easy to.
Can you write a small readme dot patches or whatever file?
do that.
Please run these 3 lines and everything is
So
fine.
the thing to be combined with what Matthias said about this general document or just paper of describing how to contribute to OMNeT. That's the process, these are the limits, these are the rules, these are the persons.
I think it's all boils down to
Actually, a feature on GitHub that you can provide, you don't have to do that, but you can provide a markdown file, which I think is called contribution.md, and then just goes up in the repository on the headline, like, right, read that if you want to contribute to that repository. So, yeah, you know, just set up a wiki page or whatever.
I think especially for backporting things to private repositories, which I guess we all maintain, I think it's crucial to merge pull requests or to merge topic branches as opposed to rebasing them, because then I reach all pointers that say, okay, which version went into the integration problem.
Because, yeah, I mean, but the point of topic branches is that they are basically like a private branch, so it's very, very experimental until we put it into can change it anyway, or disappear or whatever. So one really shouldn't look at topic branches at all. Just as if they don't exist.
Yeah, but when new features for OMNeT, I guess, would be maintained as a topic branch up to the point where they are merged into master or the integration.
Then those are unreleased features or something. They don't exist until they have been merged.
Yeah. My main concern is what happens if I want to contribute to the OMNeT framework and thus my code merged, modified a little bit, and then I want to contribute some more. So in the end, that would be creating a new topic branch saying, okay, this is the third topic branch of the second feature. I know it's a huge deal to switch over from a linear history to this kind of thing.
Linear history makes it a lot easier to oversee, because when you look at Linux kernel history, it's like a huge railway station with 1,000 lines all over. I have no idea how they keep it working.
But it seems to work very well for them. I mean, they wouldn't have picked it just out of lazy.
Even a few stacks of papers, keeping track which comment comes from there.
And that would also solve Laura's problem of just not knowing where your code ends up. Because if people stick to merging and pulling stuff back, then you could just follow the code.
I think there are there should be two kinds of topic branches. I mean, one kind of topic branch is really private to us. Nobody really should ever see it because it's so experimental and stuff like that. And the other kind of topic branch which really shouldn't be then called topic branch. Because a topic branch, by definition, a topic branch is a short-lived branch which will cease to exist when that small feature is finished.
Okay.
So it should. So if there is a branch which is longer lived and others contribute to it, then by definition it's not a topic branch, we should call it something else. And then it's basically, it falls under different treatment, completely different policy.
What I personally would like to see is some subgrouping of the community, because we have this one mailing list and there's so much traffic, and if someone has a specific question to a specific module, I think it got lost.
Actually, there are two mailing lists. One is the global OMNeT, and there is an OMNeT developer groups, and originally that was supposed to gather people who really want to contribute and not just use OMNeT or generally OMNeT, and it's quite low traffic. So
yeah, I had previously the problem that I wanted to talk about Mixim, and the Mixim guys said, okay, use the OMNeT mailing list, but that got totally lost. And I know from the Linux kernel they have very fine subgrouping. So there are, I think, 3 maintainers of the audio for embedded things, and there's a separate mailing list. And if you have to say something about this, then you write to this mailing list. And these guys see it and it doesn't get lost in the Linux kernel mailing list.
I mean, do you see the people that are posting and that have accounts on the OMNeT mailing list? If we do like a real fine-grained number of lists, like one list for the 802.11 model, one list for CTP, one list for this, one list for that, then we could also, people are contributing or like reserving space or time for this list, and probably you also have your experts.
I don't think that those people who flood the mailing list would ever care where they post. You can't imagine through how many channels I get messages.
No.
Yeah, in mailing list my private address, to my Facebook account, to the OMNeT Facebook group, to comments on YouTube videos, and everything, and they say, please help me, how do I do wireless network simulations?
That's the first thing, we should separate the list, and the second thing would be strengthen the policy on accepting things at the mailing list or kicking things. And
I think it's tagging could help, I think, in the mailing list, but someone could take the time and tag the messages.
We tried this. I think you also had this tagging options, but people don't use it.
Yeah. Actually, I think just a small percent of people are using the web interface.
I mean, there should be someone, maybe in Budapest, whose task is to tag these messages.
In general, if the list is divided into smaller groups, it's more easy to manage them. If you have someone who is responsible for 5 posts per week, I can manage. But 500, nobody can manage. Same for you. I mean,
Yeah,
10 cannot remember.
30–50%.
If I see, okay, this is not my topic, I kick it. If this topic, it stays in the small list. It is not, kick it. After 5 kicks, he's banned. I don't know. I mean, upper mailing list must handle the same problem. So, how do you have a mailing list in Riot OS?
Yes, I mean,
how do you handle
usually, we have 2 mailing lists. There's a user mailing list for people who just use the operating system, and there's a developer mailing list who really, so for people who contribute their programs to the kernel and some of the operating system. I mean, actually, it's an operating system for embedded systems. Most of the users are developers, so the traffic volume of the user mailing list is very low. It's mainly the developer mailing list at this point. And we did not separate it in more detail. We have only the developer mailing list for all modules and so on for this operating system.
How many people? How big is the mailing list? How many people?
I don't know, but I mean there's traffic on it, and not as, I don't know. A little bit less compared to OMNeT. But yeah, I mean this actually worked out so far. Yeah, I mean the point is a little bit maybe for the OMNeT that there's a more clear distinction between users and developers. Maybe this would help to have a user mailing list and developer mailing list. I mean, you will still have users that submit something to the developer mailing list, like how can I install this and that. But maybe this the splitting will reduce this noise.
We do have some kind of splitting. We have the INET framework developers list, but
actually that's you can actually request just. So I have to manually approve your join request. So for the general user list, anybody can subscribe, and for INET, I especially require that who wants to join has to at least write down what part of INET or what part of protocols he's trying to work, and then I actually manually approve. So we have.
Yeah, but I mean, yeah, but this is only for INET versus OMNeT and the rest. And what I was saying is that you maybe also want to split for the general OMNeT mailing list to have a split between developer and users.
But is that so clear for us? I mean, we start by using examples, and sooner or later, every user tries to modify something to gain his goal. Because all our researchers want to try this, test this, and it's something else that the initial writer had in mind, or some different parameters, something that is not working right.
I mean, parameters is users. I mean, it's not developing for me, from my understanding.
Actually, I think my distinction between user and developer is that a developer is someone who intends to improve INET, either via a bug fix or discussing some meaningful way, but or maybe contributing code back. So he has plans to do that. But if you just want to solve your homework or just want a quick solution, that's not a developer. And
No.
I would say that actually it's not so clear what's the difference between developer, because at the end everybody will write some C++ code or something, or at least have to look into that. So it's hard, so maybe it's much better to decide it on the intention of the people, whether they want to contribute something, finding a bug or suggesting a feature or something like that.
And also in the Wireshark project, we also use two publicly available mailing lists, which is the users and the developers list. And no more fine-grained thing like a dissector list or a infrastructure list or whatever. So basically, you filter that stuff out. I mean, if you're only interested in this part, just scan through the mails and ignore what you're not interested in. Linux is much more complex, but it works there. But I think even in Wireshark, two lists, and then we have some private lists for where commit messages go and that kind of stuff, which is not, you don't subscribe to that, you get subscribed to that. The other stuff is just two lists. And
some specific regulations for posts, where you say, okay, the post to this list should be from.
No, I mean, it's users and developers, and if there are people sending the same email to both lists at the same time and also CC it to a lot of core developers just to get a more tiny answer, and the result is they don't get it. I'm reading the same email within 5 minutes. I'm losing interest in answering.
Yeah.
Yeah. Yeah, but maybe also this communication policy then should be made a little bit more clear on the website. I don't know. I mean, I didn't check in recent time, but maybe this needs a little bit more clarification.
I mean, you can use a contributors list. So if you're thinking about questions for people who want to contribute in some way to INET in the future, use that as a name. And because I think a lot of people will develop C++ code and might not give it back. So that might be a distinction. But make it clear what you expect from people being on this or on that mailing list, and just leave them on it.
Maybe we can also ask around, like the upper part of the group, what do people, the users of INET, still want, or what do you think, what needs to be done to strengthen the community? That was one of the points that we talked before with the organizers. What is the next step for the community? How to strengthen the OMNeT community? Is there still one OMNeT community, or are we still already small or separated framework communities, or even many islands not connected in any way? That's why the next INET release, the OMNeT release.
So, who is missing what in the INET framework?
That's one of the best posts.
Just check, there was a recent reply.
Everybody that is just, oh, I want to do this in my research, so this is missing in INET. Oh yeah, so please do. Go ahead. So this is what is missing.
It's a very good question. For example, a few years ago we thought that IPv6 was a priority, and we really didn't get around to doing it because first we had to improve IPv4 or whatever. And like, I I'm interested whether you think IPv6, for example, mobile IPv6 with its different handover policies and that kind of stuff, whether how that compares in importance with, I don't know, physical implementation various MAC protocols, wireless MAC protocols. So what do you think? Who thinks IPv6 is more important than?
Do you need an answer to that? You said
because we have certain people and they who work on topics, and we have to decide what we're going to work on next month. So if everybody says IPv6 is absolutely first priority, then next month we'll work on IPv6. If nobody cares, then we just postpone it indefinitely.
The question
doing other
is
things which are more important.
we have certain amount of resources that we can spend on INET, and actually we would like to spend it well, so it's the most useful for the community. And we need some feedback on that, because this is more or less just guessing, like we thought that, well, okay, physical layer looks, I mean, it's almost totally missing, so maybe it would be a good idea to do something, but maybe we are just we don't really know what will happen in the research community in the next year, so maybe we are just wasting the time.
I mean, the reason I was asking was that I wasn't expecting you to develop a particular protocol module. So my answer would have been, well, just wait if it's important for someone and he's willing to contribute, wait if IPv6 support gets improved.
Usually that most contributions they're not that good. So either quantity or quality. So if we would just sit around and wait until somebody comes up with a complete IPv6 code, then
but I mean, one of the features in open source is that one way of doing a project is you accept only a partial IPv6 implementation, not providing all the features, even not being very good.
In the last few years we haven't received any contributions to IPv6. In the last 2 years, we haven't received any patches for IPv6. Any patches? None.
Yeah, but the statement I wanted to make is that you don't need to wait for a very good one. Just accept one and see if it gets improved.
Yeah, but we didn't receive any. So.
Does that answer your question?
Yeah.
The question was if somebody interested in it. So obviously not.
Yeah. Well, you should have improved it. No, I mean.
I disagree a little bit. Even a bad implementation should be credited in the community. The problem is that, especially with simulation, if any piece of what you're building on is bad, is inaccurate, is messed up, is screwy in some way, everything you build on top of it is junk.
I know, and
the problem is that
for TCP it's the case.
And so the problem is that I would rather have, well, except of course I want exactly the features that I happen to use and not somebody else's. I would rather have a smaller set of features that I feel like I can really rely on, and if I build or have students build something on top of that, feel like, okay, the results we get from that are not garbage. Sometimes it feels like you're just working some wireless, you go forward, you build things, put something on top of it, you start doing tests, you start testing your own stuff, and you're like, it's kind of flaky down below, and you're suddenly pushing, and you're suddenly finding the problems of lower layers, the code that wasn't yours, and that's suddenly putting your own code, it's not putting your code into doubt, but it's putting your results into doubt. So I think I think it's really...
This is something where GitHub can be tremendously helpful, Because if you see a branch that says, okay, this is an IPv6 branch, it doesn't have to be in the INET repository, it's in some repository. You will see it visualized, branching off from implementing IPv6. Then you see, oh, there it was pulled into mainline. Then there came some few other patches. These have also been pulled. And then there's lots of other branches with people commenting on these branches saying, no, this is crap, don't do that. And then you probably don't base your code on that, but you base it on something else. And this is why I find it so hurtful to lose this history by saying, okay, all of our branches are just cut at some point and rebased into mainline, because then you lose track of what has been merged into
what's good,
mainline.
because I think it's really important to be, I think especially simulation, especially when you're building these big layered simulations where you're pulling them from various places. I feel like you're building
merge commits, you can just ask
if
your
you know the
GitHub
merges, if you
client.
know the names are really strict to get into a merge, especially if things come with tests. You know, that's really. I think before quantity, it's really some mechanism that lets us understand quality and don't feel like, oh, and this isn't just OMNeT. I mean, it's NS and you know Kuja and well, all the stuff. It's not just OMNeT, but you sometimes feel like, okay, I'm gonna grab this stuff. I might just like for myself, just opening up a bag of headaches or.
Oh, sorry.
But I mean, the important point is, and this is a generic one, is like about making sure what the status of the code quality is. So, like a very good infrastructure for tests. So, this is something I would say. This is a good job for you to provide an infrastructure for testing, a generic infrastructure for testing, from very simple ones to very detailed ones, which then can be used by different protocol layers. And then you can look on how many tests are there for this stack or for that stack and how good it is. And you might not find someone being interested in doing this generic infrastructure work. You might find easier people working on a particular protocol, and if they get this infrastructure, they will benefit from it. And you could ask, please implement this amount of tests, or do these tests, or provide a way of running them automatically, or this kind of stuff. This will be very helpful for improving people to submit patches.
I absolutely agree. That would be very helpful. And if at any point in time someone writes a test and proves that part of the code is wrong, you can just ask your Git client, okay, is this broken code in my model? And it will just tell you, yeah, that was merged some years ago. And this is why I also find it so helpful to have history. To be able to see, is this commit, is this in my repository? And then something you just lose if you read this. You have basically no idea what code is in your repository.
And I mean, I didn't mean, you said you don't want to have bad code in that. I agree with the bad infrastructure stuff, but the point I wanted to make is someone could start with a subset of the IPv6 functionality and say, okay, here's the start, and someone else could improve this and add different features or parameter support or whatever. And if such testing framework is there, you would just add tests and you could still make sure that it continues to run.
But I think there's a distinction between a subset where that subset is of high quality and a subset of functionality where you just don't know what it's not. You have a subset of functionality that's very high quality. It does that subset well and correctly, and I think that's good to encourage. It doesn't have to be complete. But it should be, what is there should be correct.
Yeah. And high quality you could define by, there are test cases provided, and you say, okay, these test cases cover what I would expect, so.
Yeah, I think that's important, because just the problem with the simulation is that if any part of it is messed up, in big ways or small ways, you just don't know, you feel very unconfident in your simulation results, and the community feels unconfident in your simulation results. As well. But I think really
a proper test farm is a very good testing infrastructure. That's something that is accepted, coupled together with being able to reproduce what code is in my model. And
I think it's characterization. I think it would be nice if we go back to these various wireless models, is just to have some characterization information. how do these things behave? What's packet loss as a function of distance, packet loss as a function of signal strength? Go through some of the scenarios where we understand what should happen, and say, okay, do these? They're never going to look like testbed results, just because that's a very different sort of problem. But at least people can say, okay, here's what the simulation of the lower layer is doing, and is it transmitting 800 meters without error, or is it transmitting 20 meters without error? Do I feel like I can see it? Like what I see in there? I think that would really help more than adding this feature or that protocol. Is just being able to increase the confidence in what's there.
And for different layers, you want different ways of testing. So the transport layer would really love to see packet-based things. So you send this method. This method flow exactly has to happen, and then internal state has to be like this. So, which is very different from what you need from your layers.
No, I think that's very true, and I think for some layers, the behaviors are very well defined, and there are already good correctness tests from that just need to be perhaps brought in some other. And I assume that Linux and all the other kernels have some way of testing their TCP. TCP performance should be well understood. It should be something that you sometimes it's well. There are situations where
it's not trivial to test TCP.
No, it's not. But there are. But the point is, it's been a non-trivial problem for a lot of people. I mean, it is a widely unsolved problem, which makes it very interesting to work with. So I think that would be my suggestion.
Yes, that's a good end. We need to
One more question. For 802.11 thing, we plan to deliver refactoring on the 802.11 model because originally it was written as a B model, and then people kept adding different standards like G and A and E and I don't know, all letters, and then the double letters as well. So now it's getting really messy. So what we want to do is basically split out some the basic functionality, how to transmit a frame, how to wait for some certain period and stuff like that, and refactor the rest of it, all the other letters into other classes, which and so my question is, who has worked with 802.11 code recently? Who knows?
I faced that problem actually, so I had to validate it more than mix it, and I understood that you had only the D version. So as a suggestion, it would be much easier if you split according to the transmission text, like .11a. .11g in that case, N, AC, and AA, all of them they are OFTM based. So then the thing you have to do is basically a small function that takes bandwidth as input, and then you give the bit rate, for instance, you can give that to the Mac layer. And just be aware of the preambles, because .11 has different preambles, and because of the compatibility, and .11g as well, because of backwards compatibility with .11b. So that could be the easiest way. Otherwise, you will have to copy the code from .11a and change the small parameter for .11a, and you don't want to do that. So.
Okay, it's the same question. I mean, the question is also has to do
be looking for some people who would be open to discuss the 802.11 model with. So, like experts or reviewers for the 802.11 model. So if we do some things, we could go into discussions whether that's a good way to start changing the code or not. So, is there someone who's worked with 802.11 model, Mac model, isn't it? You?
Not yet, but I will in the next month.
Okay.
So.
But he is also.
Yeah, I wrote the 11p model for Wayne's, and I also wrote
So, say your name. Say your name.
Someone has to write it down.
I mean, I need to interrupt this a little bit because